Welcome to Managerial Economics. Today we are going to review some important economic concepts that you may have met in the first year of B1003, Economics for Sustainable Business. Okay, managerial economics. What is managerial economics? It's the use of economic analysis to make business decisions involving the best use of an organization's scarce resources. Several important points here. First, resources are scarce. We don't have unlimited resources. So because of scarcity of resources, we need to make some trade-off. So that we have a best use of these resources. Here's a review of economic term. Microeconomics is the study of individual consumers and producers in specific markets. We look at supply, demand, pricing, output, etc., etc. On the other hand, we have macroeconomics. It's a study of aggregate economy. So we study the whole economy, the economy as a whole. It is concerned with like GDP, unemployment rate, inflation, fiscal policy, monetary policy, etc. Okay, I said before that resources are scarce. So this scarcity, because of this scarcity, we need to decide what to produce, how to produce, and for whom to produce. And in doing so, there's an important concept here, opportunity cost. What is the opportunity cost? It's the cost of the foregone, it's the cost of the value of foregone second-best options. For example, an example here is, suppose, say, you come to class. So class, you value it at $100. If you do not come to class, you can say you have other options. Say you can go shopping and you value it at $60. Or you can watch a movie. You value it at $80. So now, what's the opportunity cost of coming to class? As I said, the opportunity cost is the cost of the foregone second best options. Okay, so what's the second best? If you don't come to class, you can either go shopping or watch movie. So now, watch movie is the second best, other than coming to class. So clearly, the opportunity cost is $80. So that's the concept of opportunity costs. Okay, managerial economics deals firms a lot. So what is a firm? A firm is a collection of resources that is transformed into products demanded by consumers. Basically, in economics, we are going to treat the firms as a kind of black box. And you put something into the black box, you get some output. So that's the firm. Firm has a goal. In economics, we generally assume that the firm's goal is to maximize its profit. Certainly, that's the working hypothesis we have. And you can argue that there are other goals that firms want to have. That's fine. Okay, profit denoted by pi. Profit, what is profit? Is a firm's revenue, total revenue, take away the costs. Okay, here costs. Here we need to be careful here. Cost, total cost here we mean economic costs. It's different from accounting costs. different in the sense that economic costs are based on replacement cost and also include opportunity cost. So it includes opportunity cost. Let me give you an example here. Suppose you are, say you are running a pizza shop, baking pizza, and you hire 10 workers, and you yourself also work in a pizza shop as well. So 10 workers plus yourself. Say you act as the manager. So that's yourself. So 10 workers, the salary per day is $100. So now the cost for you is total cost, the cost, not total cost, the cost here is equal to 10 multiplied by $100 cost per day. So that's $1,000. And this is gonna be our accounting costs. But that's not all. This is not all. We are not finished here. Because you yourself work in the shop, so there's an opportunity cost associated with here. You can think this way. If you don't work in your pizza shop, you might work elsewhere, and you can earn a salary there. So there's an opportunity cost associated with working in your own shop. So you need to account for this. Suppose if you work, say, instead of working in your pizza shop, you work, say, in supermarket, you earn $200 per day. Then you got to add this $200 up here. So that your total cost is $1,200. And this is expressive cost. Or loosely, you can think that they involve money flowing out of your pocket. And this is implicit cost or opportunity cost. Opportunity cost. Okay, so that's the important thing that you want to be aware of. That's our working hypothesis is that a firm maximizes its profit. Okay. Before we move further, let me give you some revisions on the first year economics that you have, supply and demand. Okay. Hopefully, you can still remember this. So, we have a diagram like this. On the vertical axis is price. On the horizontal axis is quantity. Okay. Usually, when we put something on the vertical axis, we implicitly assume that this one depends on this one. But this is not the case for our supply and demand diagram. Okay, just be aware of this. Demand, it relates the equation, and it is a functional relation between price and the quantity of demand. So demand is downward sloping. So that's demand. We call it, this downward sloping, we call law of demand. Basically, it says that price increases, demand decreases. Price increases, demand decreases. So that's demand. We also have supply. Supply is upward sloping. Supply. Supply describes a firm's marginal cost of production. Later in the next few weeks, we are going to get to know more about this. Okay, supply and demand, but for this moment, just take this as given. We have supply and demand. Demand downward sloping, we call this no demand, supply upward sloping. Then we have market equilibrium. Market equilibrium is the intersection point. Why is this intersection point is the equilibrium? Because at this point, quantity of supply is equal to quantity of demand. Quantity of supply is equal to quantity of demand. Okay, let's say at this point E, there's an associate price. So that's the equilibrium price of this market and associate quantity, equilibrium quantity of this market. You can think this as a market for banana or market for apple, market for whatever you want. Okay, then you may ask why this point should be an equilibrium. Okay, let's say, suppose not. Suppose prices happen to be at this level. Instead of being at an equilibrium level, price is at this level. Let's say suppose, for some reason. Then, given price at this level, firms are willing to supply this many to the market, but consumers are only willing to buy this many. So now there's an excess supply. Excess. So there are more supply than demand in the market. And this excess supply is going to put the downward pressure on the price. Price need to go down. So in the end, the price is going to go down. As the price goes down, the excess supply decrease until it reaches the equilibrium point where the excess supply is zero. Okay, that's why point E is equilibrium. It's equilibrium. Okay. So in the market, we have supply and demand. Okay, suppose this is the market for banana. Market for banana. Initially, equilibrium has this many. Say equilibrium price for banana is $2. $2. Equilibrium quantity says a Q star. Could be 1 million kilograms or whatever quantity it is. Okay, and equilibrium form is E. We can use this supply and demand diagram for more powerful analysis. Let's suppose that a few years ago, we have Cyclone Yasi comes in the North Queensland. So what Cyclone Yasi did is that it blew down all banana trees. Then what's going to happen to the banana price in the supermarket? We can use this diagram to analyze this. Okay, since banana trees were blown down, they cannot no longer produce bananas. So the supply definitely will shift to the left. Which means at every price level, at this price level, previous the supply is going to be this many, but now it's going to be this many because we got fewer banana trees to produce banana now. So supply curve shift to the left. So this is S prime, shift to the left. Clearly, now you're going to see the market equilibrium is going to move from E to F, move up along this demand curve. So now we see that banana price increased to $10, from $2 to increase to $10. product quantity, equivalent quantity decrease. Q1 start from start. So product price increases because of second Elasticity blow away all the product trees, price increases, quantity decreases. And indeed, we observe that after the second Elasticity, the product price indeed skyrocket to like $7 per kilo. Alright, so that's the supply and demand diagrams. Okay, the last important concept I want to cover in today's lecture is the elasticity. Elasticity, a very, very important concept here. There are different types of elasticity. What is elasticity? It measures how sensitive one thing responds to another thing's change. Okay, for example, we have price elasticity of demand. Price elasticity of demand. Of demand. Price elasticity of demand, it measures how sensitive for 1% price change, how many quantity of demand will change. So how sensitive the demand is to the change in the price. Okay, so let's say we use epsilon to denote this price elasticity of demand. So if price change by 1%, delta here is the change of price divided by price. So you get a percentage of change. If price increases by 1%, how many quantity will change? So if price, example, let me give you an example here. If price increase by 10%, and we observe that quantity of demand decreased by 20%. So now the price elasticity demand will be minus 20% divided by 10%. So it's minus 2. So that's price elasticity demand. You'll notice that price elasticity demand is negative. And this is because of low demand. The price increases, demand decreases, or the other way. You can sometimes, most often, you can ignore the negative sign because we know it's negative. So you can say that price elasticity of demand is 2. We know it's going to be negative. We know price increases, demand decreases. Okay, so you can ignore that one. The sign in the front. Okay, so that's the formula. We call it price elasticity demand. Price elasticity demand, percentage change of price. For if price increases by 1%, how many quantity will increase? So now we can write this way. We can move P up, P here, multiply both P on both top and bottom, and this cancel out. Multiply both Q on top and bottom, and this cancel out. So now we can rearrange the terms, become this over Q. Okay. Okay, so that's in these terms here has an interpretation. What is that term? Okay, let's look at the picture. So that's demand looks like this. Downward sloping. It's demand. Okay, usually we are going to see demand as straight downward sloping line. So that's demand. There are other shapes that could have that is possible, but for our subject, we are going to all have this sort of straight line demand. Okay, Then this dq over the change of q over change of p is the slope here. The slope here is equal to change of p over change of q. So now this one is just the inverse of slope of this demand function. So that means that on this straight line, at different points, we get different elasticity. For example, at this point, okay, is elasticity equal to dq over dp, so which is fixed because it's straight line, so it's fixed. Multiply p over q. P at this point here, p is equal to this many. Q is 0. So now at this point we are dividing something by 0. Mathematically, this is not defined, but you can think that we can divide something by a very, very small number, infinitesimally small number. So when we divide something by a very, very, very small number, we get infinity. So here, elasticity at this point is infinity. Okay, let's look at elasticity at this point. At this point, what's the elasticity at this point? Let's look at the formula here. dq over dp, which is a fixed number because it's a straight line, multiply p over q. What is p at this point? P is 0, q is this many, p is 0. So at this point, elasticity is 0. So if we move from this point down to this point, we observe that elasticity if we move from this point down to this point along this demand curve, then we observe that elasticity decreases from very, very big infinity down to 0. So suddenly you see that at some point in between where elasticity is equal to 1, which means that if price increases by 1%, demand will decrease by 1%. So this elasticity equal to 1. So for all points located in this segment, we get elasticity bigger than 1, and we call it is elastic. Demand here is elastic because elasticity is bigger than 1. All points here, elasticity is less than 1. We call it inelastic. Okay, so that's elasticity. That's the concept of elasticity. And certainly we have different other types of elasticity, like elasticity of supply, elasticity of income. Similarly, they are defined in very similar ways. So 1%, for example, like price elasticity of supply. If price increased by 1%, how many percentage will the quantity of supply increase? Income elasticity of demand. If income increased by 1%, how many percent will the quantity of demand change? Okay, that's pretty much the concept that we want to cover for this week. And I'll see you next week.